So today we're going to start Chapter 5. In Section 5.1, we are addressing the idea of randomness. So before we do this, let's just kind of refresh ourselves with a definition and look at what we mean by probabilities as well. So probabilities are long-run relative frequencies used to describe processes where the outcome depends on chance. If we remember, a relative frequency is either a ratio or a percent that we looked at all the way back in our first chapter. In this section, we will investigate the idea of randomness and how it relates to the idea of probability. So we're going to connect this idea of probability with these long-run frequencies and then look at randomness and what that means as we kind of compare those. All right, so to begin with, we're going to start with the definition. We use the word random to describe events that seem to happen with no purpose or things that have no apparent pattern. However, in statistics, the word random has a much more precise meaning. In statistics, random means that no predictable pattern occurs and no outcome is more likely to happen than any other. So all of our outcomes have an equal chance of happening and then no predictable pattern of our outcomes occurs. People are not good at identifying truly random samples or random experiments, so we need to rely on outside mechanisms such as coin flips, random number tables, or computers or calculators that have random number generators. So in our first example here, we're going to look at a couple different examples of random coin flips. So a student was asked to imagine flipping a coin 20 times and write down the resulting heads and tails. Right, his results, and then we see these listed right here in this line. So these are student generated. Right? He didn't actually do anything, he just imagined and came up with our results. Right? And then to compare this to an actual random occurrence, an actual coin was flipped 20 times. And these are the results that we see for the actual coin. What do we notice about the results? So I went ahead and wrote out the answer to this one just because we're going to end up with a pretty long paragraph here, so that way we can just kind of talk a little bit about our answer. All right, so if we compare what the student came up with to our list of our actual experiment, the student limits the lengths of streaks to a maximum of 3 in a row, assuming more than that would not seem random. So if we look at this first list, the longest thing that we see as far as streaks go, we see a streak of 3 tails here, a streak of 3 heads here, where if we look at this one, we notice that there are some much longer streaks, right? So there's a streak of 3, 5, 4, right? There are also in our students list more single occurrences of heads or tails. Right? It's natural for us to think about going back and forth. So if we're imagining something, there's a lot of cases where it goes back and forth between tails, heads, and then tails again. Where if we look at this one down here, there's only a couple of single occurrences down at the end. Right? So the truly random experiment showed longer streaks, right, as we just saw. Less individual tosses, so less back and forth with only individual values, and overall less pattern. Right? So when we're thinking about random, again, what we think of as random as people and what is truly random can be a little bit different. So that's why we're going to explore some other tools to come up with and use to generate random sequences.